I want to start this by talking about base 10 counting. So everyone hold up your fingers. You may put your fingers down now. I've mentioned before that part of the reason our culture uses base 10 counting is because we have 10 fingers. You actually perceive 10 to be an even number, the only reason being that once we write down all 10 digits that we have, starting with 0, 5, 6, 7, 8, 9, to get to the next one, we now increment the 1 before the 9, and the 9 returns to a 0. You have seen this happen in numerous things where if I kind of perceive this a little bit differently, where let's say that I have this is 1, then it's 2, and we skip ahead and it's 8, and then it's 9. At the very, 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 very next slot, this one goes to 0 and this one goes to 1. And that's how our numbering system works in base 10 counting. Let me give you another more visceral example of this. There's a whole list of kind of humorous YouTube video, or not YouTube videos, kind of old math. If you ever search mom and pa kettle math, there's lots of misconceptions about how this happens. $24 multiplied by 5 people for all of you would be what? 25 times 5. Okay, we're going to pretend like you guys can get to 120, but and yet you all would know that adding 24 to itself 5 times, I guarantee that there's a section of the population that if I were to give this problem to would add them up by counting 4, then 8, then 12, then 16, then 20, then 22, 24, 26, 28, and 30, and tell me that this is equal to 30, and be more than fine with that. And believe me, they do not really understand where the mistake is. But I want one of you to think about what the misconception is called. Where in elementary school did this idea that that is inherently wrong plant itself? This is something that elementary teachers deal with. And what is the concept? If you were to look at the unit plan and the big ideas and all these standards that are out there for state and national councils of teachers of mathematics and things that have to happen at certain grade levels, this particular one is probably a first grade thing. What would it be? What's it called? And to put this, period 5 got this almost immediately with the same questioning. What is it called when you perceive the 2 in front of the 24 to be different from the 4? Yes. And place value is the concept that lets you guys understand that this number is not the same thing as the number 14. This does not represent 3, a 4, and a 7. This represents something different. And this is how we do our mathematics. We actually, in the Arabic numeral system, choose to do it this way instead of the Roman numeral system that does this, then this, then this, then this, which is a different way to kind of achieve a similar result. So going back to the idea of place value. And again, I'm going back on a review. I want you guys to see this as not just 3, 4, 7, but 3 what? And then 40 and 7. And I want to kind of go with Robbie on this one because I heard you say something a little bit more valuable. Not just 300, but 3 hundreds plus 4 tens and 7 ones. And just so you guys can kind of understand how base systems work in different number systems, where I get the 10 from is that the 100 is a 10 to the second the 10 is a 10 to the first, and the 1 is a 10 to the 0th. And I'm showing you that because you can go infinitely far left and right and have 10 to the thirds, 10 to the fourth, 10 to the fifth. You can also go left or right and do 10 to the -1, 10 to the -2. That's your decimal points. That should be a plus. You're right. So this is how our number system works. And I bring this up because your first question and your only question really for the day is the product of a 2-digit number and its tens digit is 50. The ones digit is 3 more than the tens digit. Find the number. These aren't meant to be tricky questions, but they can be because they're not very visceral compared to things like we're going to cut squares out of the corner of a box and fold it up. A lot of these questions will be 2-variable questions, and it's probably easiest on you to set them up as 2-variable questions. But can you tell me what your 2 variables will be? I heard x and x plus 3. I'm going to hold on that for a second. We're going to do that as one of our equations. And I'm going to go x and y, but that would be a perfectly acceptable way to go about it because that's going to be a single variable approach. But I want to start with what x is actually equal to. When I ask you guys what are my variables, I'm not asking you to give me 2 letters of the alphabet. I'm actually asking you to tell me what they would be defined as. So what are the 2 unknown quantities here? Will someone raise hand and tell me? Krishna, you just have to raise your hand. What Krishna? Okay, so if x is the number itself, we don't have a way to break up the pieces of the number, and that's the issue. So I need to kind of go a little bit different. Tess? Okay, we can let x be the tens digit, which means that we can also then let y equal the ones digit. Now, the number itself, is not xy. You don't multiply the tens digit times the ones digit to get to the number itself. I then would have people tell me that the number then is the same thing as x plus y, but if that were true, then you would just be adding up all the digits of the number to tell me what the number is, and that doesn't make sense. Jack, you want to take a? Jack's saying 10x plus y, 10 times the tens digit plus 1 times the ones digit. If there was a hundreds digit, you would multiply it by? 100. This is about the same thing as the coin problems, where you multiply the coin times its value. Do you see the place value? It's nothing more than a term that means what's the value of the place that the number's at. So the number is actually 10x plus y. And I'm going to block this off because at the very end of the problem, when we solve for x and y, we're going to want to plug it back in here to figure out what the original number is so we can answer the question. But we don't even have an equation written down for x and y other than the one that Jania gave us, which I'm going to kind of translate here from this sense. The ones digit is 3 more than the tens digit. Let's write that one down first. The ones digit, I go direct translation, so I'm not going to put a minus in there because it says 3 more. I'm going to go y is more. 3 more means plus 3, means something plus 3, and that something plus 3 is x plus 3. I prefer direct translation of the words to symbols before you manipulate. Some of you get too caught up on mores and lesses and where it should be, and if you just read it straight through, separate the is as the equals and keep things on the left side and right side of that is, your life can be easier. So that's one. But the second one is a little bit trickier. the product of a 2-digit number and its tens digit. So I'm going to take the 2-digit number. Let's go back up. What is the 2-digit number? 10x plus y. That was what we said the number is. What's its tens digit? X. No, just x. Its tens digit we defined as x. Look at your let statements. Its tens digit is just x. So product is a word that means the answer to a multiplication. So we go 10x plus y times x is what? 50. And now here is your system of equations. Block that. Show me that you have a system. Take out a highlighter and highlight that if you have one. I want to see what your original system is before you start solving. So then we're going to now stick whatever we can, or substitute or kind of plug in where we are. I'm going to argue, let's just go ahead and plug this in right now. X, 10x plus x plus 3 is 50. Or, since I'm going to go take this a little carefully, 11x plus 3 is 50. Or 11x squared plus 3x minus 50 equals 0. For some of these, the factoring is going to be a little tricky, not completely. But for instance, I had a student come to me today and argue with me that, what was the number? That 301 should be prime, just because it's not divisible by 2 or 3, and it looks like it's prime. And yeah, 101 is prime, 201 is divisible by 3, 301, to tell if it's prime, you'd have to check all the prime numbers up to the square root of 301. And I don't know what the square root of 301 is, but I do know what squares around it are. 256 is 16 squared, 296 is 266 is 16 squared, 281, 17 squared, 324 is 18 squared. Those are the perfect squares around there. So I really would only have to check up to 17 and just only the prime number. So I have to see if it's divisible by 2, by 3, by 5, by 7, by 11, by 13, and by 17. And if I hit none of those, then it's prime. But even one of those could work. There's no prediction. Anyway, you get up to 7. You check 7, and lo and behold, 7 actually does divide that. 7 and this would be 43, which is also prime. So you can't say it's prime unless you check all of them, and that affects the factoring of something with it. This is not that crazy of factoring. So let's kind of break this up to 11x and x, because you has to be 11 and 1. 50 could be 5 and 10, 1 and 50, 2 and 25. I'm going to argue let's put the 2 here and the 25 here, so I can get a difference of 22 and 25 plus 25 minus 2. You get x is equal to 2. I'm not even bothering with x is equal to negative 25 elevenths. X is a digit. Digits are 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. We're dealing with whole numbers between 0 and 9 inclusive, because they're digits. They're actual place digits. So x is 2. When x is 2, y is 2 plus 3, so y is 5. And what's the number? Yeah. The number is, we look back up, 10x's plus y's. So 10 2's plus 5. The number is 25. Basically, I had to go back over that with a few today. I had to say, well, we defined 2 as the tens digit and 5 as the ones digit, so isn't that 25? But the number is 25. So like I said, that's the only actual problem we're going to do. I want to show you some things that are going to kind of come up on these. You have done these before, but let's get a few things straight in your head right now. First of all, you're going to see some area problems. And your area problems mean that you need to show, and you need to kind of diagram things out. I am big now on diagramming. Show lots of space. I've seen some of your homeworks that, for the last section, are really cramming things into small margins of corners of paper. So like the systems problems from yesterday, my period 5, we won't make fun of any people. That's not my style. But no, we'll call this one Halia Ackett. Might have like taken the last 3 and crammed them into the corner of the last final page on the back side. And I know a twin would not do that. So in these problems, make sure that you are showing lots and lots of space. Area problems. You guys know 2 things about this right away. If that's a rectangle, you know that its area is equal to, and its perimeter is equal to, 2L plus 2W, or 2 times L plus W, quantity L plus W. When you take just L plus W, that's called a semi-perimeter. That's not a perimeter. Don't go there. Okay, next, we're going to draw a triangle, and I'm going to try to make this be kind of an obtuse or just a weird one. I know that triangles have 3 sides. Literally why they're triangles, but that's the 3-angle thing. Perimeter would be the sum of all 3. Let's say that I drop a height down, and I can say that the area would be equal to 1/2 base times height. Base here is C, isn't it? So that'd be 1/2 CH, the way I drew it. And let's say hypothetically that I actually drew a right angle there. What would the area also be? 1/2 AB. And let's say that this is a right triangle. I might be able to establish another relationship. A squared plus B squared is C squared in a right triangle. So all of those could be true. Later in math, you guys will learn a formula that gives you the area of a triangle given all 3 sides, even if it's not a right triangle. It's a very, very useful one, but it requires trig to prove it, so we don't do it yet. Let's give this. This is an image you guys have seen before, not that one, but this one, where you have this pen and your particular farmer person wants to cut down the middle or cut down the sides with so maybe on one side you're keeping wild boars, and on the other side you're keeping little mice, because that would happen. So on these, we tend to draw them with x's and y's, and I do the entire side length as a y, so that the area would be equal to what? xy. Don't make it more complicated than the area of the whole thing. We're assuming an infinitely thin fencing. But you always have this question about fencing. It's kind of like perimeter, but it's not the same. It's the perimeter of what you could draw. And 3 x's and 2 y's. Another type of problem you've seen before is a similar offshoot of that, where instead of having multiple, you actually lose one side. This is where you have the brick wall or the existing building or something like that, and you want to draw something against one of its sides. We've seen that several times already. You could label the sides x and y, and sometimes it tells you that there's 25 meters of fencing, in which case you could say fencing is equal to what? And the area is equal to x times y. See the difference between the 2? Lastly, a final type of problem that you guys have seen that's also very geometry-based comes from this. We have a box, and a rectangle, and I want to make a box. And we do this cutting out of squares from equal sides. I'm going to do this with variables here for a second, because it just becomes about taking the time to diagram this out. Let's say that this entire side length was L, and this entire side length was W, and I want to cut out squares that are x width, or x in length and x in width. I mean, they're squares. What I would kind of do is actually just draw a version of this where everything is cut out. And let's label this side now. Let's label the new length and the new width, the base of the box. So once you lose that, what's the length? 2x, yes. And this is W minus 2x. And what's each of these sides here? X, X. Why not going to draw them all? But what really happens is you end up folding this upwards to create this box. And with that box, you now have an L minus 2x, a W minus 2x, and the height of the box when you folded them upwards is x. And the volume of this box would be all three multiplied together. That's done with variables. Most often in these problems, you're given very specific numbers to plug in. You're not given variables. So the process is the same no matter what you're doing. Okay. Remember, quiz tomorrow. I'm stopping the video now.